So in a transient phenomena, we will study the variation of current in a given circuit, in a particular circuit, how the current varies. That is called as transient phenomena. The current which is going to vary in the circuit is called as transient current. Okay, transient current anta ಹೇಳ್ತೇವೆ. The phenomena is called as transient phenomena. So today we will take the important terminologies or important properties of the circuit which are necessary to understand the transient phenomena. Okay. So first of all, we will see what is electric current. Already you know about the electric current. Electric current is basically the flow of charges. It is a flow of electron from one point to another point in a conductor. That is called as electric current. This electric current is flow of charges per unit time through a conductor, and area of cross section of a conductor should be unity. So specifically, the electric current is defined as it is a rate of flow of charges per unit area of cross section of the conductor. So basically, I is equal to dq by dt, charge per unit time, flow of charges per unit time. Okay. So here in a conductor, electrons are the charges. Electrons are charges in the conductor, and electrons will move from one point to another point. So that flow of electrons is called as electric current. So that flow of electrons is called as electric current. Okay. So that thing you should know. Whenever you come across the term current or electric current, it means it is a flow of charges per unit time. Okay. So in order to understand that one, you consider a conductor. In that, there are number of free electrons in a conductor. Okay, there will be free electrons in the outermost shell. Those free electrons will move from one point to another point if external battery is connected to that, if external potential difference is connected to that conductor. Okay, so then charges will move from one point to the another point. So electrons are charge carriers, and flow of electrons constitute electric current. Okay, in conductors, electrons are charge carriers. So in conventionally, we will consider electrons as a charge carriers, and electrons will move from one point to the another point, and this flow of electrons is called as electric current. Remember, current is a flow of electrons in a conductor. Okay. Next point we'll see, in an electric circuit, the flow of current is observed if an external electric field is applied in the form of electromotive force. So without any reason, electrons will not move. So in order to observe the flow of electrons, we have to apply the external force, and that external force is called as EMF. EMF is nothing but it's an electromotive force. It is an external battery. Okay, so battery supplies the external electromotive force which makes the electron to flow. Electron flow ಆಗೋ ಮಾಡ್ತದೆ. So that is called as EMF. Full form of EMF is electromotive force. What are the conditions to observe the electric current? Okay, the electric current flows if these conditions are satisfied. What are those conditions? First condition is EMF should be applied, or there should be existence of potential difference between 2 points of the conductor. Okay, there should be potential difference. What do you mean by potential difference? So potential energy at a particular point should be different from potential energy at the other point. Okay, with respect to the electron, we have to find out the electric potential energy. Okay, so that is called as potential difference. ಅಂದ್ರೆ ಒಂದ್ ಕಡೆ ಹೈಯರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇರಬೇಕು, ಮತ್ತೊಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಲೋವರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇತ್ತಂದ್ರೆ electrons will move from higher potential region to the lower potential region. Okay, higher potential means what? The point at which large number of electrons are present. ಒಂದ್ ಕಡೆ ಜಾಸ್ತಿ electrons ಇತ್ತಂದ್ರೆ that point is called as said to be at higher potential. If there is a point which has deficiency of electrons, if there are less number of electrons in a particular region, that region is called as low potential region. Okay, so electrons will move from a higher potential region to the lower potential region. To observe that potential difference, we have to supply external EMF, external battery connect ಮಾಡಬೇಕು. So potential difference create ಮಾಡಬೇಕಂದ್ರೆ ಏನು ಮಾಡಬೇಕು? We have to supply the external battery. External battery supply ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ potential is set to be applied. Potential difference is set to be applied. Okay. Battery ಏನಿರ್ತದೆ, it has positive and negative terminal. I think you have observed the battery. Okay. Electrons lab ಅಲ್ಲಿ, physics lab ಅಲ್ಲಿ study ಮಾಡಿರ್ತಾರೆ electron. DC supply. DC supply ಏನಿದೆ, it consists of a positive terminal and a negative terminal. Positive terminal is having the deficiency of electrons. There are less number of electrons in the positive terminal. Negative terminal ante yaake helteve, there are large number of electrons. Electrons have been accumulated there. Okay, alli battery contains large number of electrons at its negative terminal. So positive terminal alli less number of electrons irtade. Because of that, there is a potential difference. Okay, if you say battery is having the 5 volt potential difference, 5 volt potential difference is under arth enu. So there is a electromotive force of 5 volt. Okay, how to define electric potential? Electric potential define ಮಾಡೋದಂಗೆ, it is work done into charge. Okay, electric potential is defined as work done into charge. Okay, oh, sorry, work done per unit charge, not work done into charge. It is a work done per unit charge. If you move the charge, that is unit charge, from one point to the another point, then the work done is said to be potential difference. Andre one electron anna negative terminal to positive terminal ತಗೊಂಬರ್ಲಿಕ್ಕೆ ಏನಾಗಬೇಕು? We have to do the work of 5 volt. Okay, 5 joules of work is done in bringing a unit charge from negative terminal to the positive terminal. Then battery is said to be 5 volt battery. Okay, so just you remember, potential difference means it is having different potentials at 2 points. One is at positive potential, another is at negative potential. That particular situation is required, that condition is required. Second point, mattondu ಏನು ಬೇಕಾಗ್ತದೆ? If there exists a conducting path between the 2 points, the electric current will flow. ಎರಡು condition ಬೇಕೇ ಬೇಕು. In order to observe the electric current, first point is there should be potential difference. One point to higher potential ಇರಬೇಕು, ಮತ್ತೊಂದು point to lower potential ಇರಬೇಕು. Second thing, these 2 points should be connected by means of a conducting path. Conducting path is necessary. Okay, conducting path necessary ಇರ್ತದೆ. So that conducting path allows the electron to flow from one point to the another point if there is a existence of potential difference. 2 points, remember, in order to observe the electric current, ಎರಡು ಪಾಯಿಂಟ್ ನೆನಪಿಟ್ಕೋಬೇಕು. ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಯಾವಾಗ ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು? ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ಈಸ್ ದರ್ ಶುಡ್ ಬಿ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್, ದರ್ ಶುಡ್ ಬಿ EMF. ಓಕೆ, ಅಂದ್ರೆ ಬ್ಯಾಟ್ರಿ ತರ ಒಂದು ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಇರಬೇಕು. ದೆನ್ ಓನ್ಲಿ ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ದಿ ಕರೆಂಟ್. ಸೊ ಬ್ಯಾಟ್ರಿ ಇಲ್ಲ, ಬ್ಯಾಟ್ರಿ 0 ವೋಲ್ಟ್ ಇತ್ತಂದ್ರೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುದಿಲ್ಲ. ನೀವು ಸ್ವಿಚ್ ಆನ್ ಮಾಡಿಲ್ಲ ಬ್ಯಾಟ್ರಿ ಅಂತಂದ್ರೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುದಿಲ್ಲ, ಬಿಕಾಸ್ potential difference is not existing. Second point, conducting path should be there between the 2 points. Conducting path irbekari, and that makes the electric current to flow. Okay, conducting path is necessary. 2 points, remember, in order to observe the electric current, potential difference should exist and conducting path between the 2 points should be existing. Okay, conductor irbeku. Insulator ನೀವು connect ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ current flow ಆಗೋದಿಲ್ಲ. That means that is the meaning. That means conducting path is necessary. Okay, this is about the electric current. Next, what is battery? So battery is a device which is a storehouse of electric field. Okay, or it is a storehouse of potential difference. Okay, and when inserted in the circuit, it provides EMF in it. Okay, new circuit alli battery connect madidre it will produce the electromotive force, EMF ಅನ್ನು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತದೆ. So it will create the potential difference. So battery is the storehouse of an electric field. Okay, so electrons are stored there. In the negative terminal, large number of electrons are there. In the positive terminal, electrons are not present. Okay. If you connect this positive and negative terminal together by means of a wire, what will happen? Electrons will move from negative terminal to the positive terminal of the battery. Okay. When potential becomes equal in positive terminal and negative terminal, battery is said to be discharged completely. Okay. Yavaga battery charge is when battery is said to have an electric field, if there is a potential difference between positive terminal and negative terminal, the battery is said to be charged. If there is no potential difference, battery is said to be completely discharged. Okay. So just to observe, battery has positive terminal and negative terminal. What happens? The electrons flow from negative terminal of the battery to the positive terminal of the battery when there is a conducting path, and that constitute current. Okay. When electrons move from negative terminal of the battery to the positive terminal of the battery through a conductor, that is called as current. So how current is observed? How electric current is observed? Current yavaga observe madabodu when electrons flow from negative terminal of the battery to the positive terminal of the battery through a conducting path. Okay. So conventionally, next point, conventionally, the direction of current is taken along the direction of flow of positive charges. Okay. In circuits now, circuit symbol use ಮಾಡಿ circuit ಹಾಕ್ತೀವಲ್ಲ, in that will represent the direction of current along the direction of flow of positive charges. Remember, electrons are negatively charged particle. That was assumed. Okay. So negatively charged particles flow ಯಾವ direction ಆಗ್ತದೆ? That is flowing opposite to the direction of positive charges. Okay. Therefore, the direction of current is always opposite to the direction of flow of electrons. Okay. Current is represented in the direction of flow of positive charges. Electrons are negatively charged particles. That's why direction of current is opposite to the direction of flow of electrons. So, suppose current is flowing from point A to point B conventionally, then it means that electrons are flowing from point B to point A. Current to A ದಿಂದ B ಹೋಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ ಅರ್ಥ ಏನು? Electrons are coming in opposite direction. Electrons are moving from point B to point A. Okay, that's point you have to remember. You remember electric current is having the direction opposite to the direction of flow of electrons. Electrons will move from negative terminal of the battery to the positive terminal of the battery, and they are assumed to be negatively charged particle. Okay, that is what the direction of current, information about the direction of current. Next, a circuit symbol of the battery. In a circuit, how this battery is represented? ಯಾವ ತರ ಈ ಬ್ಯಾಟರಿಯನ್ನು represent ಮಾಡ್ತೇವೆ? So just you observe this. So battery is represented by means of two vertical lines. Okay, one line is longer. Okay, another line is shorter. Okay, ಒಂದು longer line represent ಮಾಡ್ತೇವೆ. So you can observe the arrow mark, longer line, and another one is shorter line, and they are written very near by one another. ಇಲ್ಲಿ ಬಹಳ ಗ್ಯಾಪ್ ಬಿಡಬಾರ್ದು. There should not be large gap. So gap between this longer line and shorter line should be very small. The longer line, vertical line, represents the positive terminal of the battery. Okay. Shorter line represents negative terminal of the battery. Okay. In a battery, in a circuit symbol of the battery, the longer line represents positive terminal, shorter line represents negative terminal. Okay. So these lines are parallel and separated by small gap. Okay. So in this particular diagram, the current is flowing from positive terminal of the battery to the negative terminal of the battery. How current flows? Always conventionally. Conventionally, current will flow from positive terminal of the battery to the negative terminal of the battery. Okay, that is how the current flows. But electrons will move from opposite direction. They will move from negative terminal of the battery to the positive terminal of the battery. So this is direction of current from positive to negative. And this second figure represents the direction of flow of electrons, where electrons flow from negative terminal of the battery to the positive terminal of the battery. Okay, and I have already told you the direction of flow of current is opposed to the direction of flow of electrons. Okay, this is the circuit symbol and the direction of current and electrons. Okay, they are opposite to one another. Next, mathematically, what is the expression for electric current? How electric current is represented? Mathematically, electric current is represented by I equal to dq by dt. Already I have defined electric current is a rate of flow of charges. Okay, the rate of flow of charges is represented as dq by dt. What is q here? Q is amount of charge flowing in time dt, where time dt is very small. Okay, so I equal to dq by dt is the mathematical expression for electric current. Electric current is formula, you know, I equal to dq by dt. What is q? Amount of charge flowing. dt is time. In time dt, if q amount of charge is flowing, then current is defined as dq by dt. You remember this expression? This is very much necessary to find the relation between current and charge. Current is I, Q is charge. The relation between current and charge is given by I equal to dq by dt. Idan pade pade bekagtade while studying transient phenomena. That's why you remember this carefully. I equal to dq by dt. This is giving you the relation between I and charge Q. Current I and charge Q. Okay. Suppose you want to find out the expression for Q, what you will do? So we have to integrate this one. Okay. Then integrate you can get the expression for Q. So just you rearrange the terms, separation of variables matter. You take this dt to the other side, you will get I into dt equal to dq. Then integrate from 0 to t. Okay. So integrate this with respect to time on the left hand side, integrate this with respect to charge Q on the right hand side. I will explain. So integration gives you expression for Q. Okay. The relation expression for I is I equal to dq by dt. What is the expression for Q that can be obtained by taking the integration of this equation? We'll come to that later. But you remember, you can find the expression for Q by integrating this equation. E equation integrate madidre you can get the expression for charge Q. Okay. Next, we'll move further. So remember the circuit symbol of the battery, or it is also called as voltage source, and expression for current I. Okay. Next, there is another expression for current I. Okay. In terms of the number of charges, area of cross section of the conductor, and the drift velocity. Okay. So if current I is flowing through a conductor of area of cross section A, suppose a conductor is there and the conductor is having the area of cross section A, okay, then current I is flowing through that particular conductor due to an external electric field. What is external electric field? It is nothing but battery, okay, or EMF. Then the expression for current is given by I equal to NA VD into Q. Okay. NA VD into Q. What is N here? N is the number of charges per unit volume of the conductor. N is the number of charges. What are the number of charges here? Electrons are the charges. Number of charges per unit volume of the conductor is represented by small n. VD is called as drift velocity of the charge Q. Okay. So VD is velocity of the electron. Charge Q, here it is an electron. Q can be replaced by charge of the electron E. That is, Vd is the drift velocity of charge acquired due to the external electric field. Okay. Suppose electrons acquires some drift velocity. What is drift velocity? It is the velocity acquired by the charge due to the external electric field. When battery is connected to the conductor, electrons will flow from negative terminal of the battery to the positive terminal of the battery. Because of the movement or because of the motion of the electron, they will acquire some velocity. Electrons they will move with certain velocity. And that velocity of the charge is called as drift velocity. Drift velocity when you connect the battery. When you switch on the battery, electrons suddenly start to move. They will get velocity. Okay. And that velocity is called as drift velocity of the charge. Okay. And here expression for I is NA Vd into Q. What is N? Number of charges per unit volume of the conductor. A is area of cross section of the conductor. Vd is drift velocity of the electron. Q is charge of the electron. You can replace this Q by small e, charge of the electron anta you consider madabodu. Okay, so this is what the expression for current says. Okay, idu kuda nenpidri. I think you have derived this expression in second PU level. The expression for current in a conductor, that expression was derived by you. So just recall the expression for current in a conductor is given by I equal to NAVD into Q. That is one of the expression for current. What is the SI unit of current? What is the SI unit of current? SI unit of the current is ampere. Ampere is the SI unit of electric current. Usually in the laboratory conditions, we will have the current in the form of milliamps. Okay, very small current will study in the laboratory. While doing the experiment in the laboratory, we'll pass the current through the components by means of milliamps. Okay, much smaller current is also observed of the order of microamps. Okay, microamp current kuda observe madtare. Ampere current is little bit larger current. Milliampere is 1000 times smaller than 1 ampere. Microampere is 1000 times less than milliampere. Milliamps andre milliamps means it is 10 to the power minus 3 ampere. Microampere means 10 to the power minus 6 ampere. Okay, that is how you can observe the unit of current. So unit of current is ampere, but in the laboratory we will use the current of the order of milliampere and microampere. Small current we will use for the study of the electrical circuit analysis. Okay, so ampere is the SI unit. So just to remember this. Next, so how charges move? So some more points about the potential difference and current. Charges always move from higher potential to lower potential region. So potential energy itself is taken as potential. Potential energy of the charge is taken as potential. Then potential antanu karite. So always charges will move from higher potential region to the lower potential region. In case of electrons, electrons will have higher potential energy if they are at negative terminal. Negative terminal they will have higher potential energy. They will move from negative terminal of the battery to the positive terminal of the battery. It means that they are moving from higher potential region to the lower potential region. So that is how charges move. Already have explained this. Next point, the potential difference between the 2 points is one of the necessary conditions for the flow of charges. Already I have discussed that. This is called potential difference between the 2 points or voltage across its 2 terminals. So idike ನಾವು ಏನಂತೇವೆ voltage ಅಂತ ಕರೀತೇವೆ. Potential difference is also called as voltage. Okay, in a battery, positive terminal is at lower potential, negative terminal is at higher potential with respect to electrons. Okay, ಯಾಕೆ negative potential, negative terminal higher potential ಇರ್ತದೆ? Because there are more number of electrons. So electrons are at higher potential. Okay, so this potential difference is called as voltage. ಈ ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಮತ್ತೆ ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್ ಡಿಫರೆನ್ಸ್ ಏನ್ ಬರ್ತದಲ್ಲ, ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್, ದಟ್ ಈಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ as voltage of the battery. Okay, and voltage of the battery is measured in volts. Volt is the unit of potential difference. Potential difference unit ಯಾವುದು? Volt. Potential difference is also called as voltage. Voltage of the battery, it is measured in volts. Okay, so this potential difference is responsible to send the current through closed conducting path called circuit. So what is circuit? Circuit is a closed conducting path. Circuit is a closed conducting path. That is called as electrical circuit. Current will flow through the circuit if it is closed, and components in the circuit must be conductors. Aವಾಗ ಮಾತ್ರ ಏನಾಗ್ತದೆ, ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತದೆ. ಸೊ ಅನದರ್ ನೆಸರಿ ಪಾಯಿಂಟ್ ಇಸ್ ದೇರ್ ಮಸ್ಟ್ ಬಿ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್. ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಇರಬೇಕು, ಕಂಡಕ್ಟಿಂಗ್ ಪಾತ್ ಇರಬೇಕು. ಸೊ 2 points ಯು ರಿಮೆಂಬರ್. ಓಕೆ, ಸೊ ವಾಟ್ ಈಸ್ ಸರ್ಕ್ಯೂಟ್? ಸರ್ಕ್ಯೂಟ್ ಅಂದ್ರೆ ಏನು? ಸರ್ಕ್ಯೂಟ್ ಈಸ್ ಇಟ್ ಇಸ್ ಎ ಕ್ಲೋಸ್ಡ್ ಪಾತ್, closed conducting path for the electric current. Okay, what is the reason behind flow of current? Potential difference. Potential difference ಇದ್ರೆ current flow ಆಗ್ತದೆ. Current flow ಆಗ್ಲಿಕ್ಕೆ ಮತ್ತೊಂದು ಕಂಡೀಷನ್ ಏನಿರಬೇಕು, there must be conducting path. The closed conducting path is called as electrical circuit. You remember this particular point. Okay, then last point, the reference level is called ground, which is at zero potential. Ground ಅಂತಂದ್ರೆ ಏನು? Ground means it's a reference level which is considered at zero potential. Ground ಅನ್ನ zero potential ಇದೆ ಅಂತ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೇವೆ. With respect to ground, what is the voltage at certain point? ಈಗ ಬ್ಯಾಟರಿಯಲ್ಲಿ negative terminal is said to be ground, which is at zero potential. Remember, it's a reference level. ನಾವು reference ತಗೊಳ್ಳೋದು ಇದನ್ನು. With respect to ground, what is the potential of positive terminal of the battery? That is 5 volt. 5 volt ಇರ್ತದೆ, negative terminal 0 potential ಇರ್ತದೆ ಅಂತ. So what is ground? Ground is the reference level which is assumed to be at 0 potential. Definition ಕೇಳಿದ್ರೆ what is ground ಅಂತ definition ಕೇಳಿದ್ರೆ in a electrical circuit. Okay, in a electrical circuit, ground ಅಂತಂದ್ರೆ ಏನು? Grounding of a point. That is nothing but it is a reference level which is assumed to be at 0 potential. What is the potential of ground? Ground is at 0 potential. 0 volt. That is one thing. Then this potential difference or voltage across two terminals is measured in volts. Then volts ಅಲ್ಲಿ measure ಮಾಡ್ತಾರೆ. Okay, so today we have studied two things. Electric current ಅಂದ್ರೆ ಏನು? Current flow ಆಗ್ಲಿಕ್ಕೆ ಏನೇನು ಬೇಕಾಗ್ತದೆ? Then what is the circuit symbol of voltage source or battery? What is the unit of current? Okay, then what is the direction of flow of current and direction of flow of electrons? And finally, what do you mean by voltage? Voltage andre enu? It is the potential difference. And what are the SI units of electric current and the potential difference? So that thing we have studied today. Next, last point we'll cover today. So basics ಅಲ್ಲಿ last point ಒಂದು Ohms law. So what does this Ohms law says? Ohms law says that the potential difference across any two terminals in a circuit and current flowing between these 2 points, they are directly proportional. V is directly proportional to I, or that is related by V equal to R into I. What is R here? R is a resistance between the 2 points, which is an obstruction to the flow of charges. Already in the previous class, I have told you, resistance is used for controlling the current. Resistance is used for controlling the current. It obstructs the current. It stops the current. Okay. So Ohm's law is given by V equal to R into I. R is a proportionality constant. Basically, V is directly proportional to I, provided the external conditions are remain constant. Temperature of the circuit, pressure of the circuit, and other conditions are remain constant. Then V is directly proportional to I. The proportionality constant is called as resistance. Already you know about it, Ohm's law. That is the one of the fundamental law or basic law in the field of electrons that is very necessary to understand the concepts. Okay, so this is Ohm's law. So remember, Ohm's law is given by V equal to R into I. Remember this. V is potential difference across the two terminals. I is the current flowing between the two terminals. R is the resistance between the two terminals. Point A and B in a circuit, the potential difference between A and B is called as V. Current flowing from point A to point B is called as I. The resistance between point A and B is called as R. They are related by very simple expression V equal to R into I. What is V? Potential difference. What is R? It is a resistance. What is I? It is a current, electric current. Okay, just remember this. So last point, this will also I will cover. IR drop. What is IR drop? Suppose a circuit is considered here, one simple circuit. A battery of potential difference V is connected. Then the current is flowing through the circuit, which is I in the circuit. Then a resistance R is connected. A resistor R is connected in a circuit, which is controlled the current. Total current flowing through the circuit is I. Potential difference applied. Current is flowing from point A to voltage of V is connected. Then according to Ohm's law, the product IR should be equal to the voltage across the resistor. Each circuit is in the voltage applied in the circuit is equal to the IR product. It is called as IR drop. IR drop. So voltage will drop across the resistor. Illi voltage drop agtade. ಎಷ್ಟು voltage drop agtade? If only one resistance is connected, entire voltage will appear across the resistance here. That is called as IR drop. What do you mean by IR drop? IR drop is the effective voltage across the terminals of the resistor. E point in the E point, positive indicate madidala, that is called as IR drop. So this is basically representing the voltage because V equal to IR. So IR drop is actually giving you the voltage across the resistor. So this you remember. Whenever a potential difference is applied, the IR drop will appear. Okay, current into resistance. That is actually voltage across the resistor. You remember this point? So this is enough today.